For this example, we need to find the domain of f of x equals 3 over x squared plus 2x plus 1. Now, in order to find the domain of a rational function, you need to take into consideration that anything, no matter what it is, over 0 is undefined. So if anything over 0 is undefined, that means that this denominator cannot be 0. It could be anything else except for 0. So we take the denominator and set it not equal to 0. So if it's not equal to 0, we have to solve for x and figure out what x cannot be. And to solve for x here, we have to factor. So if we factor this, we get x and x plus plus. Multiples of 1 that add to give you 2 are 1 and 1. Now we can apply the zero product property that states if you have anything multiplied together to make 0, that means that one could be 0 or the other could be 0. So I'm just going to make both of these equal to 0. Now they're both the same thing, so we're going to get the same answer either way. But sometimes they're not going to be the same. So you know that x cannot be -1. So I'm going to put this in interval notation first, and then we're going to put it in set builder notation. For interval notation, if you put this on a graph, it might be a little bit more clear. If you have 0 here, -1 here, you know x cannot be -1. So we're going to put an open circle at -1. But if -1 is the only number that x cannot be, that means it can be anything on this side, and it can be anything on this side. Remember, this side is -infinity, this side is infinity. So in interval notation, the shading goes from -infinity, remember infinities always have parentheses, all the way to -1. And this also needs a parentheses because it's an open circle. Then there's a union at -1. But because it's only at -1, it starts up again right after -1. So you use another parentheses. And it goes all the way to infinity. So this is interval notation. But if we want to use this in set builder notation, we can do x such that, and we just use our solution we got up here. X cannot equal -1.